Hello everyone. Today we're gonna talk about I think it's this way. Today we're gonna talk about Chebyshev rule, an empirical rule for your exam. So Chebyshev is when the distribution is not normal. And this basically means the shape normally is like a bell shape. The shape is unknown and it gives us a minimum percentage, while empirical rule, the data is already normally distributed, and this always gives us an accurate percentage since it's going to be more accurate. Let's see. When I talk about bell shape, I meant like that. If yes. And then okay. I think the easiest way to know when it's Chebyshev or empirical during your exams or tests is Dr. Leitner will always put the data is normally distributed, or she just won't say it at all. And sometimes it's tricky because I get confused too sometimes. So, okay, we can get started. So, this data set, a mean is 80, their standard dev is 5, and it is no information given about the distribution. So from this, I'm gonna say it's Chebyshev rule. And I give you this, and now we're gonna find how to actually get the K to do that. So the K and the Z is basically the same. So I'm gonna do this. So I'm gonna do 70 minus the mean divided by 5, and 90 minus the mean divided by 5. And this, normally you should get one negative and one positive, and divided by 5. This one's gonna be -2, and this one's gonna be +2. If this was normally distributed, we would just stop here, but it's not. So now we're gonna do 1 minus 1k squared. So these are our k's. So you can pick either one since it's gonna be squared. 2 squared. I have to finish this quickly. It's gonna be 75%. And this just means at least 75% with the mean equal to 80 and their standard dev is equal to 5. Okay, and now we're gonna do the next problem. This one is normally distributed. Is normally distributed with a mean of 60 and a standard dev of 4. These are our x's. So for z, it's gonna be basically the same thing. And this is empirical rule because it's normally distributed. So I'm gonna do 56 minus 60 over 4 and 64 minus 60 over 4. This should be -1 and this should be 1. And I want you to take a look at right here. These symbols are for population, but it's the same. It's the same for sample too. So this is plus or minus 1 standard deviation, and the percentage for 1 is 68.26%. And then we're gonna do the next one. It's gonna be a mean of 100, standard of 10, and there's no information given about distribution. So I'm gonna do Chebyshev rule. And we're gonna find K first. K is gonna be equal to the X, and then it's gonna be 1 minus 1K squared. So I have 70 minus 100 divided by 10, and then I have 130 minus 100 divided by 10, and that's gonna be 30. That should be -3 and +3. Yeah. And with this, I'm gonna do 1 minus 1 3 squared. You can do, it doesn't matter which 3 you use because it's gonna be 1/9 anyways. So 1 minus 1/9 is equal to 0.88, and this is basically 88.9%. So 88.9%. Okay. And then our last question is, if it's normally distributed with a mean of 5, standard of 6, what would the percentage be for these x's? And it's normally distributed, so I'm gonna do the z is equal to 32 minus our mean divided by 6, and 68 minus our mean divided by 6. So 32 minus 50. There should be -3, and this should be +3. And with this, we're gonna look at this one, because this is plus or minus 3 standard dev. So plus or minus is 99.73%. Okay. I'm gonna just highlight these all real quick. So I have 99, this, Chebyshev, Empirical, Oh, I didn't write it for that one, but that's okay. I hope this helped you to know the difference between Empirical and Chebyshev. And if you watch it to the end, thank you. I hope this helped you, and have a great day.